The sun was expected to lie low, to simmer beneath the surface, but instead, it's roaring back to life. Scientists are now scrambling to understand what triggered this sudden intensification. In today's video, we'll dig into how solar cycle 25 defied expectations, what that means for Earth and space travel, and why the next decades may bring surprises we never saw coming. The story really begins in December 2019, when solar cycle 25 officially kicked off. Back then, most forecasts painted a quiet picture. Some even predicted it would be weaker than cycle 24. The rationale? The data trends of the previous decades had shown a slow, steady decline in solar wind strength and sunspot activity. Many researchers believed the sun was heading toward a prolonged quiet era, possibly resembling Maunder or Dalton-style minima of the past. But that assumption would soon be challenged. By 2023, sunspot counts were already climbing far above the forecasts. And by 2024, we saw a series of powerful solar storms, enough to disrupt communications and ignite auroras across parts of the globe, usually too far south for such displays. What began as a mild cycle had turned into something much more active and puzzling. But what's happening beneath the surface to cause this reversal? Let's dig in. To see how deep this change runs, NASA researchers Jamie Jasinski and Marco Velli went back to solar wind data stretching to 2008. What they discovered was startling. Virtually every measurable parameter, density, speed, temperature, magnetic field strength, pressure, was trending upward. This wasn't just a flare-up in sunspots. It was a broad, systemic intensification of the sun's output across multiple vectors. What had looked like a quiet descent reversed itself. The forecasts hadn't failed because of poor data. They failed because they didn't anticipate this kind of shift. Our models expected a continuation of downward drift. Instead, the sun was gearing for climb. This kind of reversal is a huge red flag in solar physics. It reveals how much we still don't understand about the sun's inner workings, and how assumptions, even long-held ones, can be blindsided. Why did the sun suddenly become stronger? To reveal that, we need to revisit the solar dynamo, the engine behind the sun's magnetic behavior. Models have long assumed that weakening solar winds and fading sunspots would point toward a quiet phase. But instead, the opposite emerged. One strong hypothesis suggests that the 22-year Hale cycle, the full magnetic polarity cycle, plays a more dominant role than we realized. Perhaps the 11-year cycles, rising and falling sunspot counts, are just halves of a deeper, underlying rhythm. Historical minima, the Maunder minimum, 1645 to 1715, and Dalton minimum, around 1790 to 1830, show us that the sun can stray from its usual patterns for decades. The new reversal in 2024 to 2025 may be another twist, not a return to quiet, but a surge. At stake is how we think of solar forecasting. The mismatch between predictions and reality is a signal. Our models may be too narrow, too rigid. As we watch cycle 25 unfold, it's becoming a chance to test and rebuild those models from the ground up. At first glance, this may feel like astrophysics in the abstract, but it's deeply practical. Forecasting space weather is notoriously difficult, but absolutely critical. Misjudging the sun's behavior puts satellites, spacecraft, and infrastructure at risk. If the forecasts underestimate the intensity of storms, disruptions will hit faster than we can respond. But the unexpected surge also opens a rare window. The Parker Solar Probe and the Solar Orbiter are gathering data from unprecedented vantage points, probing the near-sun environment, mapping magnetic fields, measuring particle populations. Observing the sun during this unexpected upswing gives scientists a live laboratory to refine theories, perhaps even rewrite parts of solar physics. Cycle 25's reversal is therefore not just a headache. It's a golden opportunity. A stronger sun brings real consequences, some immediate, some looming. Charged particles from solar eruptions interact with Earth's magnetic field, triggering geomagnetic storms that can knock out GPS, jam radio signals, and disable satellites. Some have already done so in 2024. We've seen how vulnerable power grids are. In 1989, a solar storm caused a massive blackout in Quebec. With modern grids built on interconnected electronics, our risk may be even greater. For missions beyond Earth, Moon, Mars, deep space, the danger intensifies. Solar storms raise radiation exposure, making long-duration missions more hazardous. Designing shields, planning routes, and timing missions now all must account for a more energetic sun. But not everything is doom. A more active sun also gives us more to study. The storms, flares, and magnetic turbulence we're seeing now are data. They are clues to processes that were hidden in weaker cycles. And on a more human level, there's wonder in it. Auroras appearing far from polar zones, nighttime skies lit up in vibrant curtains high above many regions. Even amidst risk, there's beauty and awe in what the sun can deliver. So far, solar wind strength remains below levels seen in the early 20th century. We're not yet in unknown territory, but the divergence between forecast and observation is enough to make scientists cautious. Many experts believe we may be nearing or have already passed the maximum for cycle 25. But that doesn't mean the surprises stop. The declining phase of a cycle can be turbulent, sometimes producing long, drawn-out storms from coronal holes. Space. Also, some cycles generate last-gasp outbursts near the end, possibly pushing auroral displays and solar storm activity even further. In the coming years, we'll watch for whether the upward trend stabilizes or continues. Will the sun settle into a more predictable rhythm? Or is it entering a new era of elevated activity? The data we collect now, through missions like Parker, Solar Orbiter, and others, may give us clues that lead to breakthroughs. One of the most exciting developments, the Solar Orbiter recently captured the first ever images of the sun's poles, offering fresh insight into the magnetic dynamics at work. These polar views could be crucial in recalibrating models. Other missions, such as NASA's newly launched IMAP, Interstellar Mapping and Acceleration Probe, aim to deepen our understanding of how solar wind interacts with interstellar space. Knowledge that may help us frame these recent anomalies in a broader context. If the sun is truly waking up, we are entering a new chapter, one that demands curiosity, vigilance, and humility. The sun was supposed to stay quiet, but instead it's flexing new strength, surprising models and scientists alike. Its future behavior remains uncertain, but that uncertainty is not a drawback. It's a call to look closer, question harder, and learn faster. If you want to follow along as the sun writes its next chapter, hit subscribe and turn on notifications. We'll be watching every flare, storm, and magnetic twist with you.